Hello, hello. Wait. I'm still testing audio out. Hello, good morning, everyone. Good afternoon. Let me try a few things. So my microphone is here right now. Okay, that was a lot. All right, so what about background noise? What about echo? Can someone tell me if you hear echo on the sound? How is this sounding for you? I'm here, right? Yes, I'm on. All right. Good morning, good afternoon, good evening, everyone. How's everyone doing? Very happy to be here, as usual. D-Back, thank you. Mohammed, all right. Yes, so... Hey, Dusko, good morning. All right, so it looks like the setup is better. So I'm still working. I'm still using the new microphone that Nonoma, that Nono gave me for my birthday last week. So, but instead of having it on the table, I'm using it from a microphone arm that is hanging right on top of my face right now. So right here, the microphone is right here. You can't really see it. And I'm choosing a different sound noise reduction filter. It looks like the one that I was using last time for streaming was a little too much and was actually capping my voice and was turning on and off. Um, so I am changing back to the one that I was using before, which wasn't working with the microphone, was on the table, but it's working right now. You see, no background noise, which is great. So that's awesome. Oh, Arc Plato, thank you. And thank you for your comments. You've been leaving a lot of comments in the videos. Thanks for that. They're very sweet. I appreciate that. All right, this is a smiley face for you, Arc. All right, and it looks like my hair is cutting out. Maybe I should move the camera a little up like this. Is that true? Meh, maybe, maybe not. Who knows? Am I cutting out? Yes, I'm a little cutting out. So maybe if I do this, but then you can see the light and it looks good now. Yes, Victor, actually RTX Voice was what was giving me problems. Turns out that I have an RTX. I'm very lucky about that. And I was using GPU based noise reduction with OBS, which I was very excited about, but it turns out that it wasn't working that great. It was too much. It was a super noise. The canceling was a lot very strong. It was stopping my voice and then it would turn on and off randomly. I don't know if you watched the last live stream, but the audio was not great. No. And Nono is very particular and very demanding about audio quality, so he gave me a thumbs down and I cannot. If Nono says it's not working, I have to fix it, you know? He's my audio guru. So no. I was using what was I using? Let me show you here. Where was I? I was using RTX audio canceling. Nah. RTX voice? No, but wait. RTX noise canceling. Is this what I was using? I don't think. Wait, so let me see. Is this... Oh, who's calling? Oh, spam. Let me see. What was I using? NVIDIA noise. So can you see here? I was using the NVIDIA noise removal that I installed somewhere. Where did I get this from? GPU noise canceling. RTX voice. I think it's probably the same thing. Where did I get this from? NVIDIA noise canceling. But it wasn't the broadcast app. No, it wasn't through this, but it was similar to this. Victor, can you help me find where did I download this from? Okay, I think was this? No, 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 no. No, but it wasn't through the broadcast app. Audio effect. This is what I was doing. Yes. So I was downloading this audio effects for OBS Studio. Is this the same as RTX Voice? A new version of the in the NVIDIA broadcast app. RTX Voice is now enabled for NVIDIA GeForce, Quadro, and Titan. And download the app for RTX, NVIDIA Broadcast, RTX Voice. Noise reduction for OBS. Microphone. But it goes through the broadcast app. I see. Well, this version I haven't tried myself, but I tried this version. So downloading audio effects, and then it just shows up as a filter. Yeah, but I'm assuming they probably both use the same GPU based sort of. Is this the is this the shadow of the microphone? You see this? This is the shadow of the microphone. Wow, that's crazy. Okay. Yeah, that's maybe two different things. Good morning, Andres. All right. Oh, can I say something? I want to feature a couple things today. First, Jim is back on track. Jim is a fellow parametric camper who used to do this thing where he would post on his blog things that he had learned from the channel. And I think he just did a couple of blog posts about the videos we recorded last week about dynamic simulation, which I think is pretty cool. And he is referencing the videos that we do, which is also something to be thankful for. It's like fair game. So I think it's very nice. I very much recommend everyone to check his work, Chen Chi Yuan. So I'm gonna post this link here on the channel. And I also want to remind, I don't know if you follow me on Instagram or whatever, but where is my, yes, but to this afternoon, today at 6 p.m. my time, we have for the class that I teach at the Harvard Graduate School of Design, the Introduction to Computational Design. Every year we do guest lectures by people from industry and academia, etc. And we're starting the guest lecture series today, actually. And the first guest is Andrew Human, whom you probably already know from like his 20 plus Grasshopper plugins, Human UI, Meta Hopper, JSwan. Those are probably my favorites. So he's going to be talking about his work and as a software developer, and as an architect. And this is going to be live streamed for free publicly for everyone on YouTube. So if you go here to my link tree, you can find a link to my YouTube channel with the live stream that is going to happen today at 6 p.m. All right. So you're more than welcome to join for that. And what else are we doing today? Well, a few things. If you're new to this channel, welcome. My name is Jose Luis, Parametric Cam. We do computational design tutorials, you know, all that stuff. And if you want to follow us, we have some social media. This is where we post when we go live. We record, we do live streams here, and then we edit them and we post them as videos or series, etc., etc. So that's great. And if you want to know when we go live, We're pretty active on Instagram and Instagram stories, for example, so you can follow us there. Or we have a Google calendar that you can subscribe to. It's in the description on this video, and then it will tell you when we go live. And also during the week we have offline conversations, and I announce when we go live also on a Discord server that we have. The shadow of the microphone is quite intense. We also have a Discord server that you can sign up, and we have offline conversations, etc., etc. So you're welcome to follow us. Welcome to join us there. It's in the description of this video. Okay. And what are we doing today? Today is going to be a little special because instead of recording tutorials, like clean, polished tutorials that we typically do, today is going to be a research day. What does that mean? It means that there are a few videos in the Advanced Development in Grasshopper series that we are currently recording that rely on a few things and a few examples that I need to research. So today is not going to be a nice, clean recording of a tutorial. It's going to be me trying things out and like experimenting, etc. So I don't know if that's interesting to you or that's boring. I leave that choice up to you. But what we're going to do today is that we're going to explore this C# library that I've been meaning to get my hands on, which is called Geometry 3#. And it's done by this gentleman called Ryan Schmidt, who has a lot of really cool stuff, especially with meshes. So this library is actually pretty good for meshes because he himself was the creator of a bunch of really cool stuff, like for example, Mixer. I don't know if you remember Mesh Mixer is a product that was acquired by Autodesk, and that it was acquired by Autodesk, and it's a product specifically for doing mesh manipulation, generating support structure for 3D prints and all that stuff. So it's really, really good. So I think this library, I'm actually quite excited because it has a lot of mesh functionality, which, for example, it's something that we don't really have that powerful in Grasshopper because Rhino is a bit more nerves oriented than it is mesh oriented. So what I would like to do is, because farther down the road, I want to record a couple tutorials where I show you how to load an external library in Grasshopper and how to use it in Grasshopper. What I would like to do is I would like to use this library to load it in Grasshopper and do mesh manipulation in a way that we can't do natively. However, I have never used this. I literally have never used this. So I'm going to use this tutorial to just explore what the library looks like, where the documentation is. I'm going to try to do some vector algebra with the library, and hopefully my goal today is to come up with a way of taking a Grasshopper mesh, converting it into a Geometry 3# mesh, then doing some kind of manipulation like simplifying the mesh or I don't know, creating support material or something like that, and then converting it back to a Grasshopper mesh. That because those are the techniques that I will want to explain once I record the tutorial on how to load libraries and assemblies and how to use them inside of Grasshopper. So that's what we're doing today. So today is going to be messy, it's going to be bumpy, it's going to be me like, well, what the hell, how do we use this, etc., etc. So if you're excited about that, follow along. Otherwise, maybe take off and then see you back next week when I will have probably controlled this and then the tutorial will be nice and smooth and clean, etc., etc. But if you want to learn how I do research on other people's work, then perhaps today is a good tutorial to follow. All right. Beautiful. So I guess we're gonna get started. So hello, this is Geometry 3#, and let's get our hands on in figuring out how to use this library and how to write C# applications that use the power of Geometry 3#. The first thing I'm going to do is I'm going to figure out where's the documentation. So I have a bunch of tutorials here, but it looks like there's a Nougat package. So that's great. And there's a bunch of tutorials. I wonder, and then these are the main classes. So we have a vector, units, memory pool. We have some math, frames. Oh, frames, position and orientation. That's cool. I like that. Frame transformation, free, minimum rotation, frame to alignment, ray plane intersection. Frames are awesome. And you should use them instead of matrices. I like this. I'm already loving this library. Ryan Schmidt, thank you very much. I really like this already. Okay, I really agree that frames are somehow way more intuitive. It's the same as a matrix, actually. It's still like 16 numbers, really. But there's something more intuitive to matrices for some reason. To me. Then we have solvers, approximation, Gauss points. We have colors with floats and bytes. We have distance queries, intersection queries, containment. We have meshes, so simple mesh is probably where I will want to be. Looks like backed by d-vector buffers. So we will need to see what is the d-vector. D-vector index list with vector style interface, but internally stored as separate blocks of memory. Appending is amortized 01. Never a full buffer copy like a normal list. Okay. All right. Mesh is the dynamic mesh class. So this is probably have edge internally. Topology, data stores of d-vector, submesh, subregion of a d-mesh, edge loop, Remeasure, Remeasure Pro. This is probably what we want to use. For example, reducer, edge collapse, mesh simplification using quadric error metric. I have no idea what that means, but it sounds very sexy. Mesh editor, low-level mesh editing operations, append, triangle, mesh transforms, normals, weights, mesh. You see how much mesh stuff is in here? This is great. Marching cubes, that's also very cool. Mesh vertex, mesh operations, mesh extrude, mesh plane cut. This is pretty cool. Mesh cut. Cut one mesh with another and optionally remove contained regions. Nice. Spatial data structures. Point AABB3. Point set. Bitmaps. 2D curves. Polygon nerves. Ah, it has nerves. That it uses B-spline basis internally, which works in any dimension. That's cool. 2D computational geometry. Convex hull. Is there a convex hull 3D? There isn't? That's surprising. It feels like something... SVG writer, this is very cool. STL reader and writer, also very cool. That's very cool. Unity interoperability. Ah, this is great. So I guess vector F G3 vector. And this is interoperability. All right. This sounds sexy. Okay, so what are we going to do? Well, the first thing we're going to do is we're going to write a simple example, probably a console application where we're just going to use this library to do a little bit of vector algebra. So that's going to be the start. So looks like this is a project. I'm going to clone the whole thing and see if I can build it. So I'm going to download, because I'm just going to download right away. I'm not interested in cloning the whole repo, because then that will give me the whole Git story. And So geometry 3 sharp master. So it looks like it doesn't have a solution. It's just a project. So I'm going to open the project file. And it gives me the readme is the file that we just saw before. Where is the d vector? D vector is in core, and I guess core is here. So d vector A is not consistent. Vector array 3t enumerator. Vector 3 g3 dot vector 3. And where is this file? Actually, where is this file? I'm a little lost right now. So we have vector 2D. And where is this? Where is the object explorer? G3 iterators. Open, containing folder. It's in math. All right. Yeah. Okay, cool. Which you see vector 2, 3, 4, D2, F segment. So D vector is probably like some other structure. Okay. So we got vectors inside of math, which I think it's how Unity treats it as well. Is that correct? I'm not sure. So we got the vector 3D class here, which is probably just like, okay, so that's the class. All right, so, and then can we build this? Can we build this solution? There is one build, and then in binary debug, we have geometry 3, which I believe is what I just built right now. So we could use this DLL, which we will eventually, but I'm going to create a new console application that is going to load the whole project as a reference. And we're going to use that as well. If this is going to be super bumpy, so if you have feedback, ideas, etc., I'm more than happy to take them. Okay, those of you who are on the chat. So I'm going to create a new project, and I'm going to call this test G3 console test, for example. I'm going to write it here, and I'm going to do a console application on the net framework. I'm going to drop this here on G3 console test, and same. Hello. Well, that was weird. Hello? Yeah, so the microphone is back, right? But why did that happen? Hello? So you can hear me now? Yes, it's working. I have I have no idea. Yeah. Well, thanks for letting me know. Yeah, like I literally saw like a lot of action. I was like, what's going on? And yep, thank you. But that was very strange. Why did that collapse? In Spanish, we have a proverb that says, stick to the bad that you know instead of the promise of something better. If it's working and you know how to control the bad stuff, then keep it around. Which I don't want to do because I really like this new microphone. So I'm going to keep trying. All right. So what if I do this? And then hold on, I'm going to disconnect. Second. Okay. All right. Hello. How about now? Now there's no shadow. And this noise canceling is still good. I think the sound levels are also pretty good. Okay, yay! So we're gonna do this. Okay, so where were we? I was saying I have loaded the whole project, not just yes. So I am using Lester. I'm using the Audio Technica ATR 2100 that Nono Martinez Alonso just bought me for my birthday, which was last week. Yes. And it's a very nice microphone because it has both USB and a regular XLR. So it can work both for digital stuff with your computer and for analog stuff, like connecting it to a mixer and just like emceeing a party, and etc. etc. So, yes, so that was nice. Yeah, no is very picky when it comes to audio. All right, thank you. Um, all right, so I was saying, I just loaded the library. So now I should be able to reference the library. So in projects, in my console application, I should be able to reference the library here. The advantage of this, as opposed to loading the DLL, is that if for some reason I want to improve or make changes on the geometry library, I can do them. And every time I run my console application, this gets built and all those changes get incorporated. Whereas the DLL is just the DLL and you can't change it. Thank you, MHMD, which I assume is Mohammed. Huh? All right. So, okay, so now let's start with my program. I have my program here and I'm going to load using geometry 3. So that's going to be that. And then let's do some E, for example, and then let's say, what am I going to do? I'm going to create a vector 3D, which stands for 3 doubles, remember? Not, and if I did 3 Fs, it would be 3 floating point values. Vector 3D, I don't know, for example, vector 3D A is going to be a new vector 3D, which is going to be, let's see what this takes. Double, an array of doubles, a copy of the vector. Is vector a class or a struct? It's a struct. Nah, that makes sense. A copy or XYCs. Yeah, so 1, 2, and 3. And then vector 3D is going to be a new vector, which is going to be 4, 5, and 6, whatever. And then how do I add them? Do we have, can I do A plus B? Is that possible? Yay, it has overloads for the operator. That's great. I'm liking this library a lot. So I'm assuming it also has negative, and it also has multiplication, which I'm assuming is going to be the dot product. And then where is math vector 3D? It doesn't have a lot of comments. That's not great. But anyway, so let's see what we have for inside of vector. So a dot, we have the absolute, the add angle D in degrees, angle in radians, I'm assuming, compared to, this is probably the cross product with another one, distance squared, dot product is finite, is normalized, the length L1, I don't know what that means, length squared, normalize, I'm assuming this normalizes the set, subtract, run, unit cross, what is this? I don't know what this means. X is a field, XY is a 2D vector. Oh, this is like in shader language. This is pretty cool, actually. Huh. Okay. All right, so let's see if this works. So let's create a vector 3D. X is going to be in the x-axis. All right, and then I'm going to copy this for y, and it's going to be y-axis, and then z should be equal to, do we have static stuff? So yes, we have the cross product between x and y. That's cool. Do we have, what else do we have statically? Angle, compute, orthogonal complement. Whoa. The function is ported from GT Engine, compute a right-handed orthonormal basis for the orthogonal complement of the input vectors. That's a mouthful to say just create a 3 vectors that are orthonormal. Yep. Said, don't get in trouble. Okay, orthonormalize. Ah, this is cool too. Ooh, all right. So, and then let's see if, can we compare vectors? So z compares the current instance with another object of the same type and returns an integer that indicates whether the current precedes, follows, or occurs in the same position in the sort order as the object. I think this is going to be not, it's going to compare the objects. It's not going to compare the c dot is finite, can compare to distance square. Well, if the cross product, well, let's first print C to the console and see what we get. And I'm getting a vector that it's 0, 0, 1, so that makes sense. So this is working well. And then can I compare with, see if, can I do the cross product of C and the internal C and see if that's 0? So vector 3D, null, none, or 0 should be probably, should be the cross product of C and the built-in 0, and this should be 0, I think, if that's correct. Yes, it's a 0 vector because both vectors are parallel. Okay, all right, so this is working. Now we need to figure out how to create, the next thing is I am going to, what am I going to do? The next thing is I'm going to do some research on the mesh. Simple mesh. Simple mesh. Okay, and simple mesh has a, what is this? Vertices, normals, colors, UVs, and then triangles and face groups. Simple mesh, initialize, copy, initialize, vector array, components, time step, append vertex. Vertices add, vertices add, vertices add, update timestamp. Okay. Append vertex, append vertices, append triangle. It's too bad that there's not a lot of comments. This could have been nicer. Insert, get vertex, normal, get vertex, new vertex info, triangle groups, public vector vertices, normals, iterator, colors, iterator, UVs, triangles, groups, vertex indices, set vertex normal, get vertex array, get vertex buffer, simple mesh builder. Interesting. Simple mesh builder has a bunch of lists and materials, append mesh. Simple mesh is a new simple mesh that we initialize with vertex normal, and then to meshes we add material assignment, active mesh, append active mesh, append triangle. Well, this is not very different from. So I guess the way we build simple meshes is that we build them, we initialize them, normals, colors, UVs, face groups, and then we can initialize it with a vector array 3D. Vector array of integers. And these are probably classes that are part of, where is this? These are probably classes that live in inside the mesh. So I guess there's going to be some transformation that we need to do between. Okay, so let's create a very simple. Let's create a super simple mesh, which is going to be. Why are we going to do this? Sketchpad. Okay. Oh, I have stuff here already. Okay. So let's create a simple mesh. I'm not going to. So we're going to do a mesh that is going to be a square. And it's going to be something like this. So it's going to be a square mesh. This is going to be 0, 0. And this is going to be vertex 0, vertex 1, vertex 2, and vertex 3. And this is going to be 0, 0. This is going to be, I don't know, 2, 0. This is going to be 2, 2. And this is going to be 0, 2. And then the face is going to be like this, for example. We're going to do this manually. Yes, so inside this, inside, don't save here, and then here. So we got simple mesh. All right, vector array. Okay, so now we're going to create, for example, we're going to say simple mesh M is going to be equal to a new simple mesh, which we initialize this? Yes. Okay, so M dot initialize, and we're going to say, do we want normals? True. Do we want colors? False. Do we want UVs? I don't really care. No. And face groups? No. None of that. And then let's say M dot append vertex. Append triangle, upper vertex. Colors equals. I guess we can start simple max triangle. Set vertex. Let's do append vertex, and that's going to be vertex info or x, y. So that's going to be 0, 0, and 0. So that's going to be, then the next one is going to be 2, 0, and then this is going to be the third one we said is this one. So that's going to be 0, 2, and then I'm going to zoom in here so that you can all see. And then that's going to be, so this is going to be 0, this is going to be 1, this is going to be 2, and this is going to be 3. Beautiful. So now I'm going to do append triangle, and the first triangle is going to be, for example, this one, and the second one is going to be this one. So the first one is going to be 0, 1, 3, because we do right hand, so that it sticks out. Oh yeah, you're right. Is this? No, what is this? Yeah, that was the microphone. Thank you, Victor. All right, append triangle is going to be 0, 1, and 3. And the other triangle is going to be, what is it going to be? 0, 3, and 2. And remember that the order 0, 3, and 2. Remember that the order matters. We have to be consistent. All right. And so what is it now? So when I add a triangle, what happens? Triangle's length, triangles add. But do we compute the normals? Initialize want normals. Okay. All right, so now I have a triangle, and then can I have the mesh? Can I just dump that to the console? How is that going to work? G3 is simple mesh. All right, so we can do better than that. So let's print something else. Add dash face groups. Get vertex normal. Has triangle. Initialize mass triangle normals, for example. Okay. The vector system triangle. Okay, so let's get face, get triangle, for example, 0. Get the first one, and let's see what we get. 0, 1, 3. Those are the integers. And this is of the type index 3i, which is probably also a custom type here. Get, how do we get vertex normal? For example, for vertex 0, I'm going to ask for that normal, and it should be probably sticking. The vertex normal is in the y direction? That sounds strange. Can I get triangle normals? It doesn't have triangle normals. All right. Well, it looks like somehow, I guess this is the mesh that we have, I guess. I wonder if now... Hey, good morning, Arasto. I wonder if we can now do some kind of operation. Mesh is standard index, mesh, remeasure. So edge, split, flip, collapse. VTX, smooth remeshing. Reducer edge, collapse mesh simplification using quadratic mesh editors. Low level mesh editing, mesh transforms. Well, let's try that. So mesh transform, what does that look like? It takes an I-deformable mesh, which I'm assuming... Okay, so for example, static void, let's say that... Okay, so let's say that I'm going to get vertex, and I'm going to get the third one. 0, 0, 1, 2, 3, the fourth one. Okay, and that was 2, 2, and 0. All right, so what that means is that if I were to translate this, so for example, let's say mesh transforms dot translate, and can I give it the mesh and then a new vector 3D 1, 1, 1, for example? Translate can take M, because I'm assuming simple mesh uses the I-deformable mesh, implements the interface. Yes, it does. Very good. So that's great. And then what that means is that if I do this again now, the vector should be somewhere else. Yep, everything is moved 1 unit. Okay, so that works. So this is a little abstract, but this is just me warming up to doing this in Grasshopper. Okay. What else? What else do we have? Remeasure. What does this mean? Mesh refiner base. Projection target, smooth types. This provides vertex control, target projection mode, no projection. I think the first thing we need to do is to understand the operation that we want to do. I think for that I'm going to go here. Mesh simplification with the G3, for example. Recently, GitHub issue, Harvard, if you want to learn more about this technique, there are papers, blah, blah, blah. We're thinking reduction from here to here. So I can create a mesh and a D mesh 3, and then I reduce it. D mesh 3. D mesh 3, mesh result. What is D mesh 3? Mesh components, mesh. It's a dynamic triangle mesh class. The mesh has connectivity, index, blah, blah, blah. The list is unsorted. There's a lot of stuff here. I wonder if we can create a D mesh 3 from a simple mesh, which is the one that we will have in Grasshopper. Although, well, let's see. D mesh 3, DM3 is going to be equal to a new D mesh from M. Can we do that? Nah, not really. Cannot convert from G3 to Boolean. Why a Boolean? Because the argument is copy, hints, etc. Component flags, a dmesh, a copy. Well, so we can copy it from the simple mesh, but maybe we can reconstruct a dmesh 3, just like we did for image 3, dm3 initialize. It doesn't have an initialize, but it has here, wait. So it has all these flags. One normals, true, no colors, no UVs, and no triangle groups, for example. And then can I append vertices? Append vertex, so 0, 0, 0. So I'm just going to copy this. dm3, append vertex. No, vertex takes 3 arguments, really? That's surprising. New vertex info, a vector. Oh, so I have to give it a vector. Interesting. That's kind of a shame. Like I would assume new vertex info with v. You see, that's one of the beauty things. So for example, let's say we wanted to extend the library right now. I can very easily just say here, I'm going to create a new method that is going to be append vertex, which is going to take a double X, a double Y, and a double Z. And what I can do is I can just say, well, here I'm going to create a new vector, which is going to be new vector 3D with its X, Y, and Z. And then I'm going to return the append vertex. So I'm going to call this function here. You see? So now append new vertex at position. So I just extended the library to incorporate a new method that takes X, Y, Z, just because I'm very lazy and I don't want to be typing new vectors here. So I want to do, you see, and now this one is using my extension to the library to append vertices from 3 doubles. All right, and if we do that, then you can see that now I have this highlight here. All right, so now I should be able to just now copy this here, and copy this here, and then this was 0, and then let's dm3 dot append triangle, and I guess this is also not gonna let me. Oh, it does. Okay, so 0, 1, and 3, and the other one is going to be 3 and 2. And this looks like I made a D3 mesh. All right, so console write dm3 and console write, for example, write line dm3 dot get vertex. For example, I'm going to get vectors in position number 3. What else do I have? dm3 dot normals. This get edge normal, get vertex normal, get vertex triangle, get triangle normal. Is this true? So I'm gonna get the triangle normal for vertex for the face 0, which should be a y vector. Let's see if that works. Okay, so I got this, which is vertex on 3, and that's in 2 and 2, and then this is a z vector, so that's the normal for this one. If I were to raise this in the z direction, that normal will get modified, correct? So let's see if I raise vertex number 1, and now it's going to be in position number 2, we're going to get some funky incline vector. I'm really liking this library. Okay. All right, I'm going to take a 1 minute break and I'll be right back. I think we're actually ready to go and try reducing the mesh and that kind of stuff and then go and do this in Grasshopper. Are you excited about this? Woohoo! We're going to do a lot of cool stuff in with meshes in Grasshopper. I'll be right back. Okay, and sound is still going on. Beautiful. Okay, so let's try now to reduce the mesh, I guess. So for example, we know how to load the mesh and then we can reduce it to triangle count. Yeah, I mean, if we only have 2 triangles, this is going to be useless, but at least we're going to try it. Let's see, we're going to try to see if it works, if it doesn't give us an error. So reducer R is going to be a new reducer with the 3CM that we just generated. So it's a private constructor? No, it's not. Yeah, and then we do say R dot reduce to vertex count, and let's see if we do 3. So what happens then? Second to it is I can reduce into, so it's pretty fast. Okay, and then what happens? DM3 has changed now. So I'm going to print the reducer, which just gives me the name of the class. But so for example, let's say dm3 dot triangle count, and then vertex count, and let's see what happens. So now I have 3. Okay, so let's print this before and after. So we're going to do before, and then we're going to do after. So you see before we had 4 vertices and 2 faces, and now we have 3 vertices and 1 face. That kind of sounds about right. And then I'm going to print each vertex to see for each vertex in, I don't know, dm3 vertices. Do I have an iterator? It's an enumerator of vector 3Ds. Yes. So I get an enumerator, and then I can print each one of the vertices. So, all right, so for some reason, the vertex that got removed was 0, 0. So it did remove this vertex. Interesting. So then it probably has remeshed. What are the colors of this thing? So then it probably has remeshed the triangle and create a new triangle that is like this. So let's see if the triangle has vertices 1, 2, and 3. That would be super cool. So let's see if that is true. And then triangle count. And then let's see the triangle. Vertices, and then triangle count. And then for each var triangle in DM3 triangles, which is giving me back, what is this giving me? An enumerator of index 3i. So I'm going to paint that triangle, and the triangle should be 1, 2, 3. No, it should be 1, 3, 2, or something like that to preserve the order as well. 2, 1, 3. Is that correct? 2, 1, 3. That maintains counterclockwise, so that's great. 2, 1, 3. Woohoo! This works. This is awesome. Okay, so we have been able to take a mesh that was 2 triangles and reduce it to 1 triangle. Yay! Hooray! Sounds amazing, right? Well, but hopefully this will be great because now we can apply this process to a more complex mesh in 3D. Correct? Beautiful. Okay, are we ready? I think we're ready for Grasshopper, aren't we? Okay, so the first thing I'm going to do is I'm going to close this. I'm going to remeasure mesh transforms, simple mesh. I don't think we're going to use simple mesh anymore because the 3 mesh gives us everything we want. It has pretty much the same interface. And it has pretty much the same interface, and except that we extended it with our new custom. Okay, so what I'm going to do now then is I'm going to close my console application. I'm going to go here. This has not been, well, this has been updated because if you see the time, modified time, that's very recent. So I'm assuming this is the modification that we did with when we included the, all of these things I will explain in detail when I record the, when I do the actual tutorial. But I guess we have this now. So the next thing I'm going to do is I'm going to create a Grasshopper project. I'm going to, for the project, I'm going to take the compile library. I'm going to load it into the project, and then I'm going to create Grasshopper components. One is going to be taking a Grasshopper mesh and converting it to a D mesh 3, the native type that it uses here. Then I'm going to write a bunch of components that take that and reduce the mesh or multiply the mesh or make operations with the mesh. And then I'm going to create another component that changes, so that reverses the changes. It takes a D mesh 3 and creates a mesh, a native Grasshopper mesh. So, all right. So this is going to be G3GH test. Okay, and then for that one, I'm going to take the binary. I'm going to drop it here. I'm going to open my Rhino. And I'm going to open this one. And I need a mesh. So because, you know, because it's me and I'm very narcissistic, I'm going to take that mesh of a 3D scan of my head that I did a while ago. If I can find it. Let me see where that, I think I used that for the tutorials for the parametric camp. No? Yes, here. Meshes. Okay. Oh no, boring. I thought it would add one with my head. Mesh manipulations. Oh, wow. Yes, I did. Oh, that was bad. All right, so I'm going to copy that. I'm going to paste that. And this is my head. Ghosted. Oh, rendered. Not a lot. X-ray. I actually have a high polygon count version of this somewhere. Do I want to bring that in? Do I want to take the bunny, the Stanford bunny, if I have the bunny somewhere? Nah, I'm just gonna stick to my head. Okay, I'm going to stick to this. Okay, and then I'm going to save this in the Grasshopper test. That's going to be head, and then here C#, and then I'm going to take the mesh. I'm going to set one mesh here, and I'm going to hide it. And all right. So that's going to be the mesh. Okay, and then this component here, and then I'm going to take E3 tests. So this one is going to be a mesh, and it's going to output a G3 and a B3 B mesh 3. The input is going to be, what is it going to be? What is the mesh? Here, you can see it. Mesh is right there. So I bring it in, and the output is going to be a dmesh3 object. Okay, so what I do is I right click here, I manage assemblies, I add this, and I add geometry 3. Okay, so now when I'm here, I can go all the way to usings and say I want to be using G3, which is the library that I imported, and that works fine. And I'm going to output this. Okay, and then here, what I need to do is I need to write something that takes the mesh and creates a new dmesh. All right. So what is that going to look like? So I'm going to say dmesh3, dmesh is going to be equal to a new dmesh object, which I am going to initialize to, do I want normals? Yes. Do I want colors? No, I could say yes, actually. I guess I may want to do this just in case someone else, if I was doing this as part of a library that I was going to publish, then probably I wanted all of this to be true so that I can give folks as much flexibility as possible, but I don't really care right now. And then I don't need to initialize this. So what I need to do is now I need to iterate over all the vertices in the original mesh. So initialize, recreate all vertices. So I'm going to iterate over mesh dot vertex vertices dot count, probably, right? Is this gonna work? Yes. And then for each vertex, a vertex is what? A point? I forget. Point 3D. V is going to be mesh dot vertices. It's a mesh vertex list. And it gives me a 0.3f. Okay. So this is a 0.3f. And then I guess what I can do is dm dot add append vertex, which is going to be v dot x, which is a float. It's a single. Interesting. So I guess it's a float. Or that's the way they're calling it. V.z. Okay. And then recreate all triangles. This is gonna work. This is working still. So for int I equals 0, I is less than mesh faces, mesh face list. Okay. Which also has probably a count. Yep. This can include invalid faces. So I guess triangle would be better. Just to make sure, because maybe dmesh doesn't take triangles with 4 vertices. And then, okay, so mesh faces, what does it have? Add face, capacity count, destroy, extract faces, get face, quad count, triangle count. Remove, get face. And then this gives me a mesh face. Connected faces, topology, extract faces. Extra duplicate faces, delete faces. So I guess it's gonna be get face and mesh. It gives me a mesh face. So all right. So mesh face, and then what does mesh face has? A, B, and C compared to is triangle. Well, since we decided we're going to stick to triangles only, I'm going to say, hey, no, we were just talking about you and the microphone. It's working great now. Can you hear noise? No background noise. And it's on the arm. It's great. All right, mesh faces. If it's a triangle, then append triangle, sorry. Append triangle with mf.a, mf.b, mf.c. And that's it. Correct? Yeah, and I stopped using the NVIDIA noise canceling. It was just too much. It wasn't working great. So I'm back to OBS's default noise, CPU-based noise canceling, which is kind of nice. All right, and then output is going to be the mesh 3 is going to be DM. Okay. All right, so it looks like this is working. All right, so that's great. So I got the mesh from Grasshopper that I converted into a dmesh3 object. And you know what? I kind of like this. So I'm just gonna say I'm gonna create a function, dmesh3 convert mesh, and it's going to be a native mesh, and I'm going to just copy all this code here. I'm going to initialize blah blah blah, and then here output is going to be convert mesh. Okay, and we still have the same, right? But now I have a function that is usable. What? Oh yes, I have to return the mesh. DM3. All right. DM. Okay, so we got it. So now I have a C# component that takes a Grasshopper Rhino mesh and turns it into a G3 mesh which is awesome. And now what I need to do is, for example, reduce the mesh. So for example, mesh convert, and now I'm going to write a new one that is going to be a, what is it going to be? Mesh reduce vertices. Okay, and that's going to be the mesh in. This is going to be the mesh out. To be, and then original previous vert count, and then I'm going to create another one which is going to be final vertex count. All right, so and then this is going to remain as a system object. It's going to be so because first of all we need to load here, manage assemblies, we need to load here geometry 3. We need to plug this in here. We need to use in G3, and then we need to be able to cast this to a D mesh 3, and that's going to be D mesh 3 D mesh in. Is this working? Yes, it's working. All right, so now reduce it. Oh, we need to set the target target vertices. Target vertices is going to be an integer, and that's going to be, for example, we're going to reduce it here, and we're going to say, what was it? Reducer r equals a new reducer, and we have to load the mesh, right? And then we do r dot reduce to vertex count, and then we say target vertices. All right, and then well, before that we say previous vertex count is going to be equal to dm dot vertex count. All right, and then after that we say the mesh out is going to be equal to dm, which has been reduced already. Then previous vertex count, and then final vertex count should be equal to dm dot vertex count here. Let's see if this works. Vertex, previous vertex, yes, because okay, previous vertex count and previous vertex count, and I'm going to add and remove so that it, okay, and target vertices, for example, I'm going to put a slider here and reduce to, like, I don't know, 150, something very, okay. So what do we have now? We have this, we have previous. What? How is this even possible? Ooh, something is not working well. Okay, so let's write a component in the middle to analyze for example, we're going to call this vertex analysis, mesh analysis, for example. And then what we're going to do is here we're going to do vertex count, and then here we're going to do triangle count. All right. So, and then this component is basically just going to take the mesh and it's going to tell us how many vertices and how many triangles it has. As simple as that. And then here I'm just going to cast the object, and then outputs are going to be vertex count is going to be dm.vertex count, and then triangle count is going to be equal dm.triangle count. So 4 and 4, that sucks. So it looks like, I guess the converter is not working well. What have we done here? Because obviously this mesh is analysis. Deconstruct mesh. So we have here 500 vertices, 1,000 faces. Yeah, I probably reduced this with a target of 1,000. Mesh colors, normals. So obviously, wait, and now this is changing? Oh, I guess that's because this okay, so let me clear this value. And let me disconnect this. And now let me show. So we might be messing with the references here. Yep, that's true. We're messing 502 and 1000. So this is correct. It's just that because, my suspicion is that because the object, the mesh that is coming into here is an object that gets references and that gets reduced in place, the more we do this, the more it gets reduced over itself. So I wonder if we can clone the mesh. So that we don't change it in place during the reduction. Is there some kind of method to reduce the mesh? Well, let's see. So dm.clone copy void copy. Compact copy. What does this mean? Well, I guess we're going to have to go back to the documentation. So we were here. Well, we can open the project that has basically access to it, the console application, but in the console application. So we had meshes. Yeah, fine. And then copy. What is copy? Copy, it takes a dmesh and it copies, it creates new vertices and basically copies from another dmesh. So I guess we could do that. It's kind of expensive, but I guess it is what it is. And because if I now plug this in here, this is going to change. And then if I recompute, you see this changes. And then if I recompute, yeah, this is kind of weird. Yeah, so I'm gonna need to take this and say cast, and then I'm going to copy, avoid changes to the object reference to the original object reference. And then what we can say is, for example, the mesh 3 copy equals a new the mesh 3 from we can write components. Oh, it has a copy already. Okay, so I guess we can just do. I'm going to call this cast, and then I'm going to call this DM, and then this is going to be a copy from cast, and it's going to be true and true and true and true. Does this work? Yes. All right. So am I going to expire, so disable solver, recompute, enable solver? I think I'm going to need to set one mesh again. Okay. And you can see how now this mesh stays the same. And this one, I make changes and it only reduces the vertices on the bottom. Yeah, it only reduces the vertices on this one. And it's actually quite fast, honestly. Like, they're not even, it's not even taking up. Do I have do I have the profiler? Yeah, it's not even taking up that much. That's pretty good. Okay, so then let's take another one. Let's call this mesh 2 mesh 3, mesh G3. And then I'm going to write the opposite, which is going to be, mesh G3 to mesh Grasshopper, for example. And this is going to be the mesh 3, and this is going to be mesh. And then here I'm going to say, I'm going to write another method that is going to be the other one, convert mesh, and this is going to be the mesh 3, the mesh. Okay, and then I'm going to say mesh m equals new mesh and new empty mesh. And then this is going to be mesh, and this is going to be mesh 3. And then here with the for loop, I'm going to do the same thing. I'm going to recreate all the vertices. So I'm going to say for int I equals 0, I is less than vm dot vertex count I plus plus, and then I'm going to take each one of the vertices. So that's going to be dm dot get vertex is a vector 3D, which is from G3. Oh, interesting. So get vertex is going to be 0. But if I do vector 3D, we're going to have a problem because vector 3D is also the name for Rhino. And there's going to be a conflict here because look at the error here. This is going to be interesting. You see, if I click on the error, it says that vector 3D is an ambiguous reference between Rhino geometry, vector 3D, so the standard vector 3D in Rhino, and the G3 vector 3D. So the solution to that is to be explicit here and to say this vector 3D is the one that is coming from G3. That's the one that I want to use. And then the error is now fine. And then the only thing that I need to do here is, well, I need to initialize. No, I don't need to initialize anything. Mesh dot append. What do I need to append? Another mesh? No. think I need to go through the vertex list. Is that correct? I think I need to say user data vertices dot add, and then here I want to do v dot x, and then v dot y and v dot c, which might give me problems because they're doubles. It doesn't, so that's great. And then I'm going to return m here, so that, okay, and then recreate all triangles. So for int I equals 0, I is less than dm dot what? Base count, no, so triangle count I plus plus, and so I need to use an int 3. So dm dot get triangle, that's going to be 0, and it gives me an index 3i. Okay, so index 3i IDs, and that's going to be, I'm going to call this the face or the triangle. And then m dot faces dot add face, and that's going to be mesh face. Now it's going to be the integers, so that's probably t dot a, t dot b, and t dot c. Return m, return blah. Is that correct? Okay, so that, and if I plug this in here, well, it's not gonna work. How is this working? Huh. That was strange. How did that work? Oh, because I'm still using the old method. Oh. Wait. It takes in a D3 mesh. Oh, because it's still, oh, all right. So it's, okay, so I need to make this a system object. I need to cast the object here. So dmesh3 dm is equal to dmesh3 the input dmesh. And now I'm going to cast this like this. All right, and it's not working. Unable to cast object of type, oh, because I need to plug in the output, this one. Debug is vertex, not a vertex, what? Oh my God, okay. So can I unpuff this one? Okay. And this is a regular invalid mesh. Okay, can I, what's so invalid about it? Compute normals, rebuild new normals. Okay, what if I do that? Is this now a valid mesh? It isn't. Well, what's going on here? Okay. We have a 3D mesh. Okay, so this stuff, this should give me a mesh. Let's see if we can read this one correctly. So let's see if we can read this one correctly. So let's try a couple things. cast. So that's going to be the mesh 3 cast equals this stuff here. Then cast, and then let's try A and B, and then A is going to be cast is going to be vertex count, and from B is going to be cast dot triangle count, and that should be it has an invalid mesh, and the original one has 5 O's. Okay, so if I plug the reduced one, where am I? What is going on here? So it looks like this reduction is not working great, or is creating some kind of invalid mesh. Mesh 3 debug is a vertex, not a vertex. What is that? Huh. Okay. So let's look that up here in the entire solution, and I'm going to look up not a vertex. Debug check is vertex, not a vertex. That's the only if not a vertex. Debug check is vertex. Int v. If this is not a vertex, index greater than 0. So it looks like I have an indexing problem. I have an indexing problem. Okay. So let's see. I am using this one here, correct? I'm using this one here, and this is giving me problems. So let's see if, so now it works. And A and B, okay, this is not cool. It should be, okay, so clear values, show. So why? Previous, okay. Triangle count. Oh, that's fine, yes. Okay. Vertex count. Okay, I want vertex count at the beginning, and I want triangles. Okay. Okay, so let's say I don't reduce it. I just pass it through and we're supposed to have a mesh that is valid. Maybe I'm just recreating the so does this work? This works. To mesh, but it still gives me an invalid mesh. What's so invalid about it? And then if I do this, this is probably what's gonna crash this thing, no? It doesn't crash it. And then, okay, it doesn't crash it because it's probably not processing. Wait, so now oh, wait. Oh, what? Oh, so it's only after a particular amount of reduced vertices that things crash. How about triangulation? How about triangulating the initial mesh before conversion? So that you're gonna need to have this triangle condition that might cause issues. I mean, first of all, I think this mesh is already all triangles. I don't think there's a single quad here. And then 79, what do you mean? 79, isn't it? It's a particular situation. Okay, so, all right, so this for let's figure out if recreating a mesh, a valid mesh that has been reduced. I mean, let's figure out recreating a mesh from the original. This should work because we're not passing it through any kind of. So this is, for some reason, is not working. So let's try, first of all, let's try just doing something. Maybe I'm messing something up here. So m.vertices.add. Let's do something like we did before. So literally, I'm just going to copy it from here. Like this. I'm just going to copy this and then vertices add and that vertices that add. Okay, so we're going to replace this, and this, and then this here is going to be that triangles faces dot add face, and this should be the same, and this should give us a valid. Oh yeah. Oh shit. Ugh, yeah, because I have 0 here instead of I. You know, this is the stupid. Did I say? Oh, sorry. Yeah, this happens all the time. Nah. Oh my god. Because this is I. It's not 0. I don't even know why I had that. You see? And now it has a perfect mesh. You see? The mesh is great. And this mesh is the mesh that is being translated between the two systems. So now if I plug this in here, this is giving me an error. Okay, that's fine. But at least I'm able to slightly. Okay, so maybe. get vertex. I'm okay. At least, all right. So one problem is done. DM get vertex that I. Exactly, Fatem. Very good. You were right. 79 was the error. I just these things happen so often. So, but now we need to figure out why. Am I still outputting here a... Because this fails right away, correct? Yes. And here, why is this failing if I'm trying to iterate over? Where is this failing? Okay, so now, okay, not a vertex. I'm assuming it's failing here. Yes. Am I simply not iterating correctly? Okay, so Control undo, Control comment, DM. All right, DM is the mesh, the new mesh. I'm iterating over the vertex count, which I assume has the right amount. So maybe it's not updated. That doesn't sound correct. I mean, I'm using vertex count and triangle count. I'm using these two values. Anyway, here, so vertex count. So, okay, can I do anything such as, for example, dm dot append triangle attachment? Begin unsafe boundary cache bounds, check validity. All right, let's see, for example, C is going to be cast dot check validity. Allow non-manifold vertices, false. Check validity is true. I don't really know what this means. So it's literally, we have a problem here, which is that we are trying to iterate over vertices that do not exist, which is kind of weird because if I do 502, that's fine. But if I reduce 501, then it doesn't work. I get even though this is telling me that the mesh has 501. I'm just going to do something terrible here. 501. 300. Okay. So I can go down all the way to oh yeah, well, sorry. This is not failing because huh? So I can't get any? Huh. Weird. Okay, let's try something else. So I'm going to say C is going to be equal to cast dot get vertex and that's going to be 0. And vertex 0 is 584, 250. And in here, it is 584, 50. So I can get that one. All right, how about if I get vertex 501? Can I get that one? And then the last index of this list is 501, list item, list this one, and that's going to be the same one, right? It is the same, so I can get the vertices. So why I don't get it? Okay, so panel. There's something, I may have drunk too much coffee today. There's something really not working here. So let's say for int I equals 0, I is less than cast dot vertex count I plus plus, and then I'm going to print to the console cast dot get vertex at position I dot toString. So I can get every freaking vertex. Why is that not working here? So why can I do it here? But then, oh wait, so it's working. Oh yeah, sorry, it's working now. Okay. Okay, 460, 465, 461. Okay, hold on. We have 469 vertices. Four 64. That's going to be 464. That is the last one. And I can get that vertex here. But this is going to fail. Does not contain a definition for vertex count. Oh, okay. Why did this? Oh, because I lowercased it. It's not a vertex. Okay, so I'm going to do this. Try this. If not, catch exception x print. That's going to be I plus and then x to string. To string. Ah, so this is the problem. The problem is that there's a bunch of vertices that are just bad. The process is not clean. Ah, this sucks. Okay, so it's not me. That's a good start. I like it. I like it. But that's kind of unfortunate because I wonder if just that the process is filter vertices. What is filter vertices? Where did you get that from? Most of the mesh recorded input is manifold. This term has a lot of meanings, blah, blah, so the mesh can even represent. Preserving boundaries. Maybe the mesh is just not good. It's under mesh iterators. Can we check if the mesh is good actually? Is valid and it's valid dm dot check validity alone on manifolds. No, return only. It is true. It's under mesh iterators. And what do we do with that? Mesh iterators filter vertices as filter as there are no bow tie vertices which are these joint sets of triangles. Connect the only one. So maybe the mesh is just okay. Let's try with a simple sphere like this, for example. And let's try to bring that in. Set one mesh. Okay. And still not working. How is this still not working? Okay. Oh, because this is not a valid. Okay. Okay, so this one. Oh, I see. So it looks like mesh is vertex. I had to check if it's a valid vertex. I see. I see what you mean. I see what you mean, Victor. But so I guess that mesh was kind of a mess. The mesh was a mess. Because now we can, okay, so I can reduce this. Can I reduce this? Target vertices, final vertex. And why doesn't it get reduced anymore? Mesh sphere, vertical, I'm going to do 100, and horizontal, I'm going to do another 100. And then we're going to have this kind of complex mesh here. Set one mesh. We have 10,000 vertices. And it cannot reduce them. Huh, interesting. Oh, but it does give an error. So mesh, previous vertex is 99. So it reduces like 100 of them, but then it breaks. Oh. That sucks. I see. Victor, we're gonna try that. But this is not cool. So why is this just failing? All right, so we're going to say if cast is valid, what was it? Is vertex I, if this is true, then we're going to print this. Otherwise, else, otherwise, print invalid vertex on, and then here. Invalid vertex, blah, blah, blah. Okay, so that's a great way of figuring out the problem. So let me go back to here, set one mesh here. So we basically have a lot of invalid vertices, which kind of sucks, because then I don't know what we're gonna do with. If they're reduced, but then they're also invalid, then what's the point here? Okay. Invalid vertex. So here, I guess then now the fix here would be, all right, so for dm vertex count, we could say if if g3 vector, etc. If dm dot is vertex and then I, then we could say get this and add it to the list of vertices. So that will work. That will work, but then it will screw up the vertex numbers because now the triangles may have indices that are, oh God. This is not very clean. Recreate all triangles. DM triangle count. And then this is probably going to be in debug is not a triangle. Okay, so same thing. If DM is triangle I, if it's a valid triangle, then do this. I guess. Oh, and it has a mesh. Wait, we got a mesh. But this doesn't look right. Oh. I'm gonna take a screenshot of this. Okay. This doesn't look right. So something's going on here. I think this is going to take... Oh, going to take a little more research than I expected. So here's what I'm gonna do. I need to go because I have a lot of stuff to do this afternoon. And as a reminder, we have Andrew Human's lecture going on this afternoon. We have Andrew Human's lecture on architectural augmentation and automation. It's on YouTube. You can find the link on my personal Instagram. Here on my link tree, you can find the link to the YouTube video. And I need to prepare that. So I think I'm going to put a pin on this one. So I think what I'm going to do is I'm going to post this file, the file that I'm using right now. I'm going to post it on Discord in case any of you are really bored and you want to pick it up and you want to help me figure out what the situation is here. Yes, I'm going to do that. And then if any of you want to help or troubleshoot this and figure out a clean way to do this mesh reduction, I'll be happy to hear that. Maybe just this mesh is just too bad. But it was doing the same thing with this one. And this one is a clean mesh. I don't know what's going on here. Yeah, so I'm going to do that. I'm going to zip everything in a file. I'm going to put it on live. And if any of you wants to spend some time trying to figure this out, I will be more than happy and grateful. Otherwise, if you don't, that's also perfectly fine. I will try some other time or maybe on the next live stream, whatever. But in the meantime, thank you very much, everyone. And I hope to see you during the lecture this afternoon at 6 p.m. my time. Okay, Easter time. Thank you very much. Bye-bye.